Today we're going to work through Acceleration A worksheet. Start by putting your name on the top of the paper and follow along with me. Acceleration is the rate of change in the speed of an object. To determine the rate of acceleration, you use the formula below. The units for acceleration are meters per second or meters per second squared. Sometimes different problems will force you to use different units. That's the standard one we'll use in our class. Here we have final speed minus beginning speed. Other times you might see people indicate this as VF for V final minus VI for V initial, and then divided by the time again. A positive value for acceleration shows speeding up, and a negative value for acceleration shows slowing down. Slowing down is also called deceleration. The acceleration formula can be rearranged to solve for other variables such as final speed, V2, or VF, and time, just like this. Sometimes you might prefer to substitute the variables in and then rearrange your equation based on just your algebra, and that's fine too. That's how I prefer to do it. Here are two examples you can go through on your own. So we will go ahead and start with page 2. While traveling along a highway, a driver slows from 24 meters per second to 15 meters per second in 12 seconds. What is the automobile's acceleration? Remember that a negative value indicates a slowing down or deceleration. So I'm going to write my variables over on my left-hand side. Start with time since that's the easiest. I have 12 seconds. I'm looking for my acceleration, so I'll put a question mark there. Now I need to determine which of these numbers was my initial and which is my final. Well, it says since the driver slows from 24 meters per second, I know that must be my initial. And I have 15 for my final. He slows down to that point. So I'll write in my equation and I'll plug in what I have. Oops, I put that in wrong. Go ahead and punch that into your calculator. And you're going to get negative 0.75 meters per second squared, or meters per second, that's fine too. And you can box your answer. Number 2. A parachute on a racing dragster opens and changes the speed of a car from 85 meters per second to 45 meters per second in a period of 4.5 seconds. What is the acceleration of the dragster? So I'm going to go ahead and write in what I need to know and what I already do know. Time's always the easiest, 4.5 seconds. I don't know my acceleration. It says that he changes the speed of the car from 85 to 45. So it was 85 initially, and then it slows to 45. So I'll write in my equation. My final is 45. And I can plug that into my calculator. So he was decelerating at a rate of negative 8.9 meters per second squared. Number 3. A car traveling at a speed of 30 meters per second encounters an emergency and comes to a complete stop. So if you're completely stopped, you're not moving. So it's 0 meters per second. How much time will it take? So I'm looking for my time. For the car to stop if it decelerates at -4 meters per second squared. So my acceleration is actually deceleration, so it's -4.0 meters per second squared. I'm looking for my time. It was traveling at that 30 meters per second initially, and then came to a complete stop, so its final was 0. So plug in my equation, and I'll plug in what I know. Here I'm going to cross multiply, so I'll do -4 times t equals 0 meters per second minus 30 meters per second. And I'll have to divide this by -4. So this will cancel out. I'll have t on its own. And then I can plug this into my equation. 0 minus 30 equals -30 divided by -4 will give us 7.5. Now I can go ahead and cancel out these things, so I'm alone with one a negative s on my denominator, or I can just know that it's seconds because that's the unit of time I'm dealing with. Oh, it looks like our numbering got off here, so this must be number 4. A cart rolling down an incline for 5 seconds has an acceleration of 4 meters per second. If the cart has a beginning speed of 2 meters per second, what is its final speed? Okay, so we'll write down what we know and what we don't know. 5 seconds. I'm looking for my final speed. I have an acceleration of 4 meters per second squared, and it has a beginning speed, an initial of 2.0 meters per second. I'll plug that into my equation. I can go ahead and cross multiply. So I'm going to have 4 meters per second squared times 5 seconds. Actually, I'll keep going actually. So I'm going to multiply this. Oops. 4 times 5 equals 20. And then I'm going to have to add that 2 to this side. So if I did plus 2 meters per second, plus 2 meters per second, I'll do plus 2 meters per second here. This is one of those seconds is actually going to cancel out, so it's going to give me 22 meters per second is going to be my final velocity. Okay, you can square your answer. Then we'll move on to our last worksheet, or last page of the worksheet. And I guess they're all rearranged differently, but that's okay. So we'll just say this is number 7. A helicopter increases from 25 meters per second to 60 meters per second in 5 seconds. What is the acceleration? So we're looking for that acceleration. So A equals question mark, VF, VI, and time. Again, time is always the easiest. Time here is 5 seconds. I'm looking for my acceleration. It increases, so it must have started at the 25 meters per second to 60 meters per second. So plug that in. I'll plug that into my equation. 60 minus 25 equals 35 divided by 5 is going to be equal to 7 meters per second squared. Number 8. As she climbs a hill, a cyclist slows down from 25 miles per hour to 6 miles per hour in 10 seconds. What is her deceleration? So deceleration again is a type of acceleration. So we're looking for A. T is 10 seconds. So she slows down from 25. So her initial is 25 to her final of 6 miles per hour. And we'll plug that into our equation. Six minus 25 equals, divided by 10, it's going to give us a negative 1.9 meters per second squared. That's our deceleration. Number 8. A motorcycle traveling at 25 meters per second accelerates at a rate of 7 meters per second squared for 6 seconds. What was that final speed? So our initial is 25 meters per second at a rate of, so that rate is 7 meters per second squared. She went for 6 seconds. The final speed is what we're looking for. So we're going to cross multiply. So one of these, this is a numerator, so that's a denominator. So one of those will cancel out. You can plug that into your calculator if you'd like. We're going to add that 25 to each side. You can add 42 plus 25. It's going to give us 67. So she must have been going 67 miles or meters per second for her final speed. Number 9. A car starting from rest. So if the car starts at rest at 0 meters per second, accelerates at a rate of 8 meters per second. What is the final speed at the end of 4 seconds? End of 4 seconds. We're looking for final speed. Our acceleration was that rate of 8 meters per second. And she started from rest, so 0 meters per second. So we'll plug in what we know. Going to go ahead and cross multiply. And this is one of the numerator and denominator. So I'm going to add 0 to each side. So the final velocity must have been 32 meters per second. Number 10. A skateboarder traveling at 7 meters per second rolls to a stop at the top of a ramp in 3 seconds. So he rolls to a stop, so that's going to be 0 meters per second. What is the skateboarder's acceleration? Move this up some. We're looking for acceleration. Three seconds is our time. Traveling at 7 meters per second initially to stop, and we'll plug in what we have. Go ahead and plug that into my calculator. 0 minus 7 equals, divided by 3 equals, negative 2.3 meters per second, or meters per second squared. So that's a deceleration. So if someone's slowing down, that would make sense that it would be a negative number. And that's it for worksheet acceleration A.